Okay. Welcome to Calbeckistan, place where anybody can learn math. I'm Mr. Calbeck, and today we're going to be talking about special right triangles. These are arguably the two most important things to memorize in all of trigonometry, and I don't care if you're in geometry, trig, or calculus, you gotta know these. If you don't know them, you need to watch this video, take some notes, and spend about 5 or 10 minutes actually practicing and memorizing. It doesn't get more important than this, okay? So here's what we're going to look at. These are special triangles. They have a special relationship that allows us to do lots of really easy calculations with them, but you got to know these first. Okay? If you have been studying geometry, you probably understood the concept of scale factor and similarity. And the idea is, if triangles have the same angle measures, their side lengths will be proportional, and we're going to be using that here. I'm going to give you some side lengths of these two. This is a 45, 45, 90 right triangle. And if I make these side lengths 1, you can actually use the Pythagorean theorem and figure out the hypotenuse. 1 squared plus 1 squared, that's 2. And if you want to find the hypotenuse, take the square root. So this has got to be the square root of 2. And over here, this is the other special right triangle. It's a 30, 60, 90 right triangle. This is half of a equilateral triangle, which is why it's really important. This is half of a square. And if we look at this one, if I pick some side lengths here, this is 1. Turns out the hypotenuse is double that, which is really cool. So the short side and the long side are doubled, and the side in the middle is the square root of 3. And again, you could use the Pythagorean theorem to find this. It's much better to memorize it because of how often you're going to use these things. Now, here's what we need to understand about special right triangles. Any triangle with these same angle measures has the same proportions as this one. And I'm going to show you a few examples, and I think I'll give you some tricks to help you solve this stuff. So let's start with the 45. If I have a larger 45, 45, 90 triangle, maybe one side is 2. Okay? And that's all the information you're given, and you're supposed to find the other side lengths. Now, normally, when you're missing side lengths in a right triangle, you need 2 of them in order to use the Pythagorean theorem. But we actually have memorized this special right triangle, so we can use the concept of proportionality in order to solve it. And what we recognize here is these two, this is an isosceles right triangle, which means the 2 side lengths are the same, have to be the same. So I know right away that this one has to be the same measure as the 2, so I'm just going to write in a 2 here. Now the question is, how do we find, is there a way we can find the hypotenuse without doing the Pythagorean theorem? And I'll show you what it is. If we think about this special right triangle here, and these side lengths can be proportional, really all I need to do is figure out what that scale factor is. The scale factor is going to be the same for all 3 sides. So I could say, well, we'll call that scale factor x. X times 1, and x times the square root of 2. So let's see if we can use this to figure out what that side length would be. Right here, I see that 1 times 2 gives you 2. It's pretty easy to do some math here. 1x equals 2. That means x has to equal 2. If you want to find the hypotenuse, you just replace x with a 2 because you've found that scale factor. So it's going to be 2 times the square root of 2. Now, the other cool thing about this is you'll start to recognize relationships within the triangle itself. So you see here, this is 1 times some number x. This is the same, so you always know that 2 sides are going to be the same, and the hypotenuse is whatever this x is tacked onto the square root of 2. And we see that here. These sides are 2, I just tack on the square root of 2 and I have the hypotenuse. Now you're welcome to actually check my work here by using the Pythagorean theorem. We could find out 2 squared plus 2 squared would have to equal c squared, which would be 4 plus 4 equals c squared. So that means 8 equals c squared. And if I want to find c, I just take the square root. And if you watched my last video, link in the description by the way, you can reduce the square root of 8 to 2 root 2. So it does work. The cool thing is you don't have to do the Pythagorean theorem if you memorize these special right triangles. Now they're going to show up all the time once you learn trig. If you're already in trig right now, I'm sure you've seen a ton of stuff with these kind of square roots of 2 in them. It's very, very common. Okay? Let's take a look at another example and see if we can figure it out. Again, I'm going to leave this up here so that we can use it. Let's imagine instead that I've got this number 4 here. I know this is a 45, and you got to figure out what these guys are. Okay, this one's a little trickier because you were given the hypotenuse, but you can think about it in terms of the scale factor. If you can find the scale factor, just multiply it by 1 and you've got those side lengths. So I'm going to set this equal. I know that the square root of 2 times something is going to give me 4. So I'm going to go ahead and set those equal to each other. So it's just going to be x times the square root of 2 equals 4. Now I'm hoping this is going to be relatively easy for most of you to solve. X times something, I do the opposite, which is division. Divide both sides by square root of 2. And I get x equals 4 over the square root of 2. And if you watched my last video, link in the description, you can rationalize this denominator. Remember, all you have to do is multiply by a big 1 and make that big 1 the denominator. So the denominator right now is square root of 2, so I'll make that square root of 2 over square root of 2, which is 4 root 2 over 2, which simplifies because 4 divided by 2 is equal to 2. If you don't know how to do that, please watch that last video. It'll be really helpful. So I found x, and I know that 1 times x gives me those sides. Boom. I got it. 2 root 2. Now this looks complicated, but the crazy thing about this is you have no way of finding these 2 sides with just 1 without using that special right triangle. Again, normally you need 2 sides of the Pythagorean theorem to find the third side. Here I can do with just 1. So let me make it as simple as I can for you. If you are given a special right triangle that's a 45, 45, 90, and you're given this side right here, all you have to do, if you're given this side, is divide by square root of 2. You're getting smaller anyway, so division sort of makes sense. If you start with the small side though, and you want to find the big side, the hypotenuse, all you need to do is multiply by the square root of 2. So if given this side, all you have to do is multiply by the square root of 2. So if you're getting bigger, you multiply by square root of 2. If you're getting smaller, you divide by square root of 2. And that's all it is. Okay? And that's the cool thing about the special right triangles. They give us these great shortcuts that allow us to find very complicated problems, and that makes them very easy. Let's take a look at the 30, 60, 90. Now, just like the 45, 45, 90, these are proportional to every other 30, 60, 90 triangle, which means there is a scale factor that you can find. That scale factor is going to multiply by 1, multiply times the square root of 3, and multiply by 2. If you find that scale factor, you can find all the sides extremely easily. Okay, so you're given a problem here where you're given the short side. Now with 30, 60, 90 triangle, it's important to figure out which side is which, and it's pretty easy. If you find the 30-degree angle and draw an arrow from it, it will always point to the shortest side. So the shortest angle will point to the shortest side. We call this the opposite side from this angle. If you find the medium angle, 60 degrees, and you draw an arrow from it, it will always point towards the medium length side. Square root of 3 is about 1.7. It's smaller than 2. And if you find that right angle, that's 90 degrees. It's the biggest angle, and it's going to point towards the biggest side. Okay? So it's really helpful, particularly if your teachers give you some diagrams in different orientations, to find that right angle and make sure you're pointing directly to the hypotenuse. Otherwise, it's going to be hard to find it. So this one is all in the same orientation, but we can do it anyways and realize that the 8 is the short side. Okay, so let's see what we can do. 1x equals 8. That's a super easy one to find, right? Don't even need to do anything. This is just x equals 8. So if you know the short side, the rest is easy. You multiply it times 2 to get the hypotenuse, 16. And you multiply it times the square root of 3 to get the medium side, 8 root 3. By the way, a quick piece of vocab, the shorter sides in a triangle are called the legs. Hypotenuse is the long side of a triangle. So if you hear me talk about the legs, that's what I'm discussing. Okay, now that's the easy one. What about some harder examples? All right, so here's an example of one that's oriented a little differently, and it might be easy to mix up which one is the hypotenuse. Always find that right angle, just draw an arrow directly from it. It's gonna point towards the hypotenuse. So what I have here is one where they gave us the hypotenuse first. Now once I know the hypotenuse, I can solve for x because I know the relationship here. I can say, all right, 2x equals 20. That's an easy one to solve. Divide by 2, you get x equals 10. So the scale factor in this one is 10. It's 10 times bigger than that other triangle, or each side is at least. So that means this side has to be, again, I'm drawing from the 30, it points towards the short side, that gives me 10. And I know that 10 times the square root of 3 is the middle side. Again, square root of 3 is about 1.7, so this is about 17. But what if they gave you the middle side? That's the question mark, right? Let's try that. All right, you're supposed to find the other two missing sides here. You're given 15, and that's the middle side. And we know that because we can draw from the 30 and find the short side, and here's the hypotenuse. So this is the tricky one, but we can do the same strategy. I know that x times the square root of 3 is equal to 15. So we need to divide by the square root of 3. And unfortunately, because we have a square root in the denominator, we need to rationalize. In order to do that, I'm going to multiply by square root of 3 over square root of 3, that big 1 we've been talking about in my other videos. So if I simplify that, square root of 3 times square root of 3 is just 3. 15 times the square root of 3 is there. And I can reduce. 15 divided by 3 comes out even. It gives me 5 root 3. That's what x equals. Times 1 gives me the short side, 5 root 3. If I double that, I'm just going to erase this here so you can see a little better. As I multiply x times 2, I get the long side, 10 root 3. And again, you can check your work. Your hypotenuse should always be your longest side. If this doesn't look like the longest side to you, put it in your calculator. 10 root 3 is 17.1. This is 15. So the hypotenuse is still bigger. Okay, now let me break this down and make it as easy as humanly possible. If they give you the short side, the short leg is across from the 30. If they tell you this one, it's easy. You already have the scale factor, so you just multiply by 2 to get there, and you multiply it by the square root of 3 to get the middle side. The hypotenuse is easy because it's exactly the same thing, but we're just dividing. So if they give you the hypotenuse, you say, thank you, teacher, you gave me the easy one. Woohoo! Whatever the hypotenuse is, you just divide by 2 to get the short side. And now that you have the short side, you've got the scale factor, so you multiply times the square root of 3 to get the middle side. Okay? Can't get easier than that. If they give you the middle side, the first thing you're going to do is divide by the square root of 3 to get the short side, and then you're going to take the short side and multiply by 2 to get the hypotenuse. Again, I'd recommend if you don't have that in your notes, go ahead and rewind, get that copied down. It's very, very easy. The ultimate point of this is find that scale factor, and you can do this. But you can't do any of it if you don't have the proportions of the original special right triangle memorized. And again, I promise this is going to be one of the most important things that you can possibly memorize in geometry, trig, calculus, all that stuff. You're going to use it every day. The better you know it, the easier math is going to be. All right, thanks so much. Give me a thumbs up if you liked this video, if this was helpful. I'd love to get to 1,000 subscribers this year. I don't think it's going to happen because I'm a math teacher, and let's be honest, why are you watching this for fun? You're not, right? So, but go ahead and like and subscribe. I'd really appreciate that. And I'll catch you guys next time when we start talking about trig. See you guys.